Finally, the word problem. What's the highest number you can double and still get an answer less than 10? This is probably going to be easier to see using the bead string. So if we break off 10 and just look at that part, okay, there's 10. Right. And we can fold this in half to show what our answer will be. So if we've got 5, 1, 2, 3, 4, 5, and we double that, 6, 7, 8, 9, 10, we actually get 10, but we want a number less than 10. Let's take one bead off and see what we get. If we halve this, we can't quite get a whole number. So we get rid of one more, and now we can see that 2 times 4 is 8. 1, 2, 3, 4, 5, 6, 7, 8. It was easier, I can show you with the coins. So 1, 2, 3, 4 coins. If we double that, we get 8, which is less than 10. But if we had 5 coins to start with and doubled that, we would get 10, which is too many. So the answer we're looking for is 4. If you did the blue questions, then we're starting at number 7. And you started with 2 times 2. So you have 2 coins to begin with. We'll double that, so you get twice as many. And the answer is 4. Number 8. 30 times 2. This is going to be easier to solve with the tens coins. So we have 30, and we're multiplying by 2, or we're doubling it. It's the same thing, doubling, timesing by 2, it's the same thing. So we get the same amount again, and now we've got 60. 10, 20, 30, 40, 50, 60. Number 9. 32 times 2 is a combination of these two questions. So when I set the questions, I set them very deliberately so that you can start to see patterns within your numbers, and that's a good way of developing mathematical thinking. So it's no coincidence that those 3 questions are very similar. But we're starting with 32 and we are doubling it. So it's the same as doubling 30 and then doubling 2. And the answer is 64. Obviously, because if 30 times 2 is 60 and 2 times 2 is 4, then you combine those answers and it gives you 64. Number 10. 43 times 2. This is now testing how well you know the method. There's 43. This time I'm going to solve it with a diagram though. So I have 43, I double 40 and I would get 80. I double 3, which is 6, and my answer would be 86. Number 11. 54 times 2. Again, this question is set very deliberately because you're going to have to go into the hundreds when you double this. So, again, this question is set very deliberately because you're going to have to go into the hundreds when you double this. So I'm going to show this with a diagram. 54. 2 times 50 is 100. 2 times 4 is 8. And the answer is 108. If you did this with coins, you would have 5 tens, 4 ones, and when you double that, you'll have another 5 tens, and another 4 ones, but when you count all the tens, you've got 10 of them. Which is the same as one of those. And your answer is 108. Finally, the word problem. What's the highest number you can double twice and still get an answer less than 100? There's all sorts of ways that you could think about working this out, but this is what I would do. I would start with my target number 100, and I got to double a number which doesn't quite get there. Well, if I doubled 50, that would be 100. So my number has got to be less than that. If I double 49, I get 98. But that's only doubling it once. If I work backwards and now halve this number, okay, then I should get my answer. So if I now halve 49, so using the same diagram, but this time I'm going to do half of 40, which is 20, and half of 9, which is 4.5. And if you're not sure about that, we can see it on these bead strings. There's 9. If I fold them in half, I can see I've got 4 on each side with 1 on the top, which I have to split in the middle, 4.5. So my answer has got to be close to 24.5. But I'm looking for a whole number. So what do I do now? I've got to ask myself, is this answer going to be 24 or 25? If it was 25 and I doubled it and doubled it again, 25 times 2 is 50, times 2 would be 100, but it needs to be less than 100, so it can't be that. Therefore, the answer must be 24. And just to check that, 24 times 2 20 times 2 would be 40, add 8 is 48, and double it again, 40 times 2 is 80, add double 8, which is 16, is 96. That gives me a number less than 100. The answer is 24. To answer the red questions, here's the solutions. (42) times 2. I'm going to do this one in my head. 40 times 2 is 80. 2 times 2 is 4, and the answer is 84. If you wanted to use a diagram to do that, this is what it would look like. Number 14. 342 times 2. Now I can actually use what I did before if I wanted to solve this. I know that 42 times 2 is 84, so I've just got to do 300 times 2. And 300 times 2 is going to be 600. So I just got to add 600 onto that. Number 15. 352 times 2. I'm going to use a diagram to solve this one. There's often many different ways that you can solve a mathematical problem. Often there's only one right answer, but there's many ways of getting to the solution. And the more tools you have at your disposal, and the more different ways you know of doing things, the more flexible you can be when it comes to your calculation. Which is also why it's important for parents not to force their own methods upon the children, but let them think for themselves and use their own methods as well. By all means, use your methods too, but be open-minded to everything that you can use to get the answer. So 552. Again, if we're going to do this as a diagram, okay, then we will double 500, which this time gives us 1,000. So we've gone into the thousands now. We're going to double 50, which gives us 100, and we're going to double 2, which gives us 4, and it's 1,104. Question 17. 2,552. Now, again, I could use a diagram for this, but I've just noticed that those two questions are very similar. So actually, I just need to double 2,000 and add it on to that answer. 2 times 2,000 is 4,000. Add it onto that, and I get 5,104. Finally, the problem. I think of a number, double it, and add 12. My answer is 60. What number did I think of? So let's write this down in terms of the equation and what I was thinking. So I'm thinking of a number. I then double it, and then I add 12. My answer is 60. What number was I thinking of? In later videos, I'm going to be sharing with you bar modeling as well, which is another really good way of visualizing problems, but I'm going to just briefly show you this now and how it works. I'm going to put this in a diagram form so it's easy to see. My final number was 60. I added 12 on at the end to get that number, but before I did that, I doubled the number I started with. So in order to find my answer, I've got to work backwards. So I start with 60, and I take off 12. So this number here is 48. And then I halve 48 to get my answer. And it's 24. So I hope you've enjoyed today's lessons on doubling, and I hope you found it really, really useful. My final challenge to you now is to head back to the problem we saw at the start of the lesson and see if you can solve it. See how far you can get. If you're in year 1 or 2, maybe just see how many squares you can do. Just do a few squares from the first row. If you're in years 3 and 4, see how many rows you can do. Maybe you can do 2 or 3 rows. If you're in year 5 and 6, try and solve the whole thing. See if you get right to the end and get the final answer. And if any of you do get the final answer, then head over to my Facebook page, Help at Maths, and post your answer on there. And let's see who's first to solve the problem. Good luck, and I'll see you next time.